Assalamu alaikum students. So today the new lecture is about partial fraction. Why we need partial fraction, and in mathematics how we can use partial fraction in many things. So partial fraction is can be used in finding the integration of a function and Laplace transform of a function or Fourier transform of a function. So with the help of partial fraction we can find the splitted components of any fraction. For example, if someone gives us an integration which is x cube plus x square dx, and they asked us to find its integration. So we cannot find directly its integration. First we have to split this fraction into its component, and we can split this fraction into its component with the help of partial fraction. So with the help of partial fraction we can split any fraction. So the splitting of a function of a fraction into its component, it is fraction, into its component is known as partial fraction. हम किसी फंक्शन को, किसी फ्रैक्शन को जब हम उसके कंपोनेंट्स में स्प्लिट करते हैं तो हम उसको क्या कहते हैं? पार्शियल fraction. So the splitting of a fraction into its component is known as partial fraction. Partial fraction, we can use partial fraction for many purposes: for finding the integration of a function, for finding Laplace transform of a function. If we see here to this function that we can't directly find its integration, because this function is so complicated if we directly find its integration. So with the help of partial fraction, first we will split into its component, then after that we will find its integration. So what is basically partial fraction? The splitting of a fraction into its component is known as partial fraction. For example, if someone gives us a fraction which is x square minus x square plus 1, or it is x square minus 1, and says us to split this fraction into its component, which is equal to 1 over x square minus 1, 1 over x plus 1 into x minus 1. That how we can split this function into its component. So there are some rules. So let me explain some points before applying partial fraction into some fractions. Applying partial fraction into some fraction. For example, we cannot apply partial fraction into improper fraction. We cannot apply partial fraction into improper fraction. There are three types of fraction. One is improper fraction, the other one is proper fraction, and one is compound fraction. So what is improper fraction? If a fraction p of x and q of x, if the degree of p of x is greater than or equal to q of x, then this fraction will be improper fraction. For example, x square plus 1 divided by x square plus 2x plus 1. This is a fraction. So if someone asks us to find its partial fraction, then we cannot directly find its partial fraction, because this is proper fraction. This is denominator and this is numerator, so the degree of denominator and numerator are same, because this is a square, this is a square, this is a quadratic equation, this is a quadratic expression, and this is a quadratic expression. So both the degrees are same. So if both the degrees are same, then it is improper fraction, and we cannot apply partial fraction into improper fraction. First we have to convert this improper fraction into proper fraction, and if the degree of p of x is greater than q of x, then this fraction will also be improper fraction, and we cannot apply, for example, x cube plus 1 divided by x square plus 1. The degree of numerator is greater than the degree of denominator, so we cannot directly find its partial fraction. First we have to convert this fraction into proper fraction, then we are eligible to apply partial fraction tools on this function. So this is the definition of improper fraction. If now the another one is proper fraction. So p of x divided by q of x. If the degree of p of x is less than q of x, then this is proper fraction, and we can apply partial fraction on the proper fraction. For example, x square plus 1 divided by x cube plus 1. So the degree of numerator is less than the degree of denominator. It is cube and it is square, it is cubic expression and it is quadratic expression. So the degree of denominator is greater than numerator. So this is a proper fraction, and we can apply the partial fraction tools on this function. And compound fraction, we can change improper fraction to proper fraction by long division method. If someone gives us a fraction, then we will transform this improper fraction to proper fraction by long division method. So for example, x square plus 1 divided by x plus 1. So the degree of numerator is greater than the degree of denominator. So this is improper fraction. So we will transform this fraction first into proper fraction by long division. So by long division, x square plus 1 divided by x plus 1. So multiply x to x, so it is x square. So x with 1, it is x, which is minus x. So minus x plus 1. So minus 1, no, minus x, minus plus 1, so minus 1. So plus 2. So it is equal to 2 plus x minus 1 divided by x plus 1. This is the So these are the main steps finding the partial fraction. If someone gives us a fraction which is x plus 1 and x minus 1, and we have to find its partial, we have to split this fraction into its component. So this is linear non-repeated factor. So there are some points for finding partial fraction of a fraction. If a fraction is proper and proper linear and the denominator consists of linear non-repeated factor, then its partial fraction will be a divided by x plus 1 plus b divided by x minus 1. If a fraction is proper and its denominator consists of linear non-repeated factor, then its partial fraction will be a divided by x plus 1 plus b divided by x minus 1. This is the first step finding the partial fraction of a function. So if I continue the above question, then it will be equal to a divided by x plus 1 plus b divided by x minus 1. So multiplying x plus 1 into x minus 1 on both sides of this equation, so 1 will be equal to a into x minus 1 plus b into x plus 1. Let x plus 1 equal to 0, then x equal to minus 1, so put x equal to minus 1. So 1 is equal to a into minus 2 plus 0, so a is equal to minus 1 over 2. Now put x is equal to x minus 1 equal to 0, so x equal to 1, so put x equal to 1 in this equation, so 1 is equal to a into 0 plus b into 2, so b is equal to 1 over 2. Now put the value of a and b in this equation, so a is equal to minus 1 over 2, so minus 1 over 2 into x plus 1 plus b is equal to 1 over 2 into x minus 1. These are the splatted fractions, and we can find the splatted fraction of any fraction in this way. This is a very simple example. In the next lectures we will find some questions which can be splatted into its fraction, splatted into its components with the help of partial fraction.